All right, well, I'm going to jump in here and we're going to talk a little bit more about equation solving. And when I'm done that, we'll have some more time for you to continue working and ask me any questions you run into. Um, so this is our fifth little mini lesson on equation solving. And what I'm basically going to start to do now, everything I've done up till now is really common to most of the courses, either in terms of what you're going to have to do or what you're going to have to do very soon. What I'm going to start to do for the rest of this week and next week is I'm going to split things up where the first lesson of each day is continuing to be those basic skills that you will run into in Math 038 and 052, or if you're in a Math 02 level course, even though you won't see it yet, you will see it as soon as you get to Math 052, and it's not specifically taught. So I think I talked a little bit about this before. There's a bit of a backwards flaw here in the whereas the comprehensive equation solving unit is in Math 053, but it comes up in some basic ways in Math 038 and 052, where you have to be able to solve some equations. In other words, to be able to move the pieces around to isolate the thing that you're looking for. And it comes up a little bit in chapter 4 of Math 052. It comes up a lot, sorry, in chapter 3, I should have said. It comes up a lot in chapter 4 of 052, where you're working with area and volume formulas and things like that, and perimeter. And that's actually what we're going to look at today is really similar types to the ones that come up in that chapter in 052. Everything we are doing is valid for 053 students, everything we're going to see. And then, so that's the first lesson of each class is going to be that stuff that's sort of important for everybody. And then the second lesson of each class is really going to focus down on the Math 053 stuff. And it's going to get you'll find a bit heavier in terms of the algebra and the fraction work that's required. So might be a little bit beyond what 038 students certainly would want to look at. 052, I mean, you're going to have to do it eventually, so it doesn't hurt to start to get the feel for what's coming in that way. So what we are going to look at this class, we're going to look at what happens when brackets come in to these equations. But before that, I've got a little recap here. So why don't we just pause here and I will give the students that are in class maybe let's just try 3 or 4 minutes and see if you can work those equations out, a little smattering of the types of stuff that we have done so far, just to get your math brain back in gear again. Okay, so let's take a look at these. What we got here is basically, last week we did 4 lessons. The first one, we just looked at plugging in an answer that was provided to you to see if it actually solved the equation. Then we did one-step equations. This is an example of a one-step equation. Then we did two-step equations. This is an example of a two-step equation. And then we did equations where the variable appeared in more than one place, which that's an example of. So on this first one, we know we're trying to get the v by itself on one side of the equal sign. It's not by itself right now because it has a -6 there with it. And then we ask ourselves the question, how is that -6 attached? It is being divided, right? V divided by -6. What is the opposite of dividing? It is multiplying. So we multiply both sides by -6, like so. And then you don't have to do this next step, but we know when we're going to have to do fraction work, we would turn that -6 into a -6/1. And now we can see, because that's multiplication, that we can cancel the -6's because there's one on the top and one on the bottom. You really don't need to show that if you just want to swipe those across right there. Or even once you really get good at it, you know that this divided by -6 becomes a multiplied by -6 on the other side. That's a little extension of the adding and subtracting idea we've already been doing a lot of. So on the left, All that's left behind is v, which was the whole point, right? That was why we multiplied by -6 to make the divided by -6 go away and get the v by itself. And once we have the v by itself, we work out the other side, 8 times -6, -48, and we have achieved the entire point of isolating. Now we can see the answer, v equals -48. Over on this next one, it's a two-step equation. Remember, the identifier of a two-step equation is that you usually have a piece with a variable, and then on the same side you have what we called a constant term, a term without a variable in it. And we also remember that we're not going to be fooled by that minus sign, right? Because we know that 19 actually has a plus in front of it. So the way that 19 is connected on this left-hand side is it is being added. Sometimes people look at this and they think, oh, it's being subtracted. But no, the 19 isn't being subtracted. Remember what we've learned, that the sign that goes after a number, so this negative sign here, has nothing to do with the number, right? The 19 is not affected by that minus sign at all. We have a positive 19, a 19 going to the right on the number line, and a negative 4x going to the left on the number line. This negative doesn't affect the 19. So we have an added 19 on the left, and we know from our practice that we can turn that into a subtracted 19 on the right, and we just do that quickly now, even though in the back of our brain, I know I keep saying that, but we know that what we actually just did is subtracted 19 from both sides. Because when we subtract 19 from the left, it goes away, plus 19 minus 19. And then we also have to do the same thing on the right? So our fast one is just to do what's in blue there, but we know, we never forget that what's really going on is what's shown in red. So we can then connect 65 minus 19 is 46. Now we still don't have the x by itself. It is being multiplied by -4. The opposite of multiplied is divided. And just yet one more quick time reminding you, notice this -4 does not turn into a +4 on the right, because this is not a subtracted 4. This is a multiplied -4. So we get rid of a multiplied -4 by dividing by -4, because you can see that on the left they cancel out. And then we got to work out the fraction work here. 46 over -4 is, that reduces. The top and bottom both divide by 2. 46 divided by 2 is 23. 4 divided by 2 is 2. And the whole thing is negative because it's a positive divided by a negative. And if they did want a mixed number, 2 goes into 23 11 times with 1 left over, so 11.5 negative. And then this last one, so we notice we have some r's over here on the left, we have some r's over here on the right of the equal sign, we have some constants on the left, we have some constants on the right, and our goal for these ones is to get everything that has a variable onto one side of the equation and everything that doesn't have a variable onto the other. So I notice that plus 12 on the left, I'm going to want to get that over to the right. And the minus 5r on the right, I'm going to want to get that over to the left. And we know that an added 12 on the left becomes a subtracted 12 on the right. And a subtracted 5r on the right becomes an added 5r on the left. And I'm not going to show it this time, but we know what we actually just did is subtracted 12 from both sides, which made it appear over here and disappear there. And we added 5r to both sides, which made this red one disappear and appear over there. Cross out remove those colors, because now we're going to want to recolor in a different way. Now that we've got all the variables on one side and all the not variables on the other side, we want to collect these together, 2r plus 5r, and collect these together, 40 minus 12. So 2r plus 5r is 7r, 40 minus 12 is 28. And now all that's left with the variable is that multiplied by 7, so I get rid of that by dividing both sides by 7. Disappears on the left, and 28 divided by 7 is 4. So there's a quick recap of the stuff we did last week. What we're going to now move into is brackets. Now, a quick reminder, because we have talked about brackets already in our little lessons here, the distributive property. So notice that these are not equations yet. I'm just reminding us how to expand brackets. There's no equal signs there. So we know that that 5 that's multiplied out front has to multiply into the bracket. And what happens there is that red minus sign is going to stay there. And we are on either side of it, we're going to multiply 5 times x and 5 times 7, like so. So you see how the minus sign stayed put, and we multiplied 5 by both the things in the brackets. 5 times x, well, that's just 5x. There's no other way to write that. 5 times 7 is 35. So this bracket expanded, it becomes 5x minus 35. Over here, similar, we got a plus sign, which I put in red. That's going to stay there in the middle. And then on either side, we're going to multiply negative 5 by each of the two things in the bracket. Negative 5 times 2t plus the red plus sign, c is still there, negative 5 times 4. So I've taken the negative 5 and I've multiplied it into the bracket, kept the sign between the things there. Negative 5 times 2t becomes negative 10t, because negative 5 times 2 is negative 10. And plus negative 20, plus negative 5 times 4. Negative 5 times 4 is negative 20. I'm probably missing a step there. This should say plus negative 20, but of course adding a negative is the same thing as subtracting, so negative 10t minus 20. So there is our expanding brackets reminder. So let's put all this together. When an equation has brackets in it, this is actually a pretty straightforward lesson here, because all we're going to do is two things we already know how to do. We're going to expand the brackets, which we already know how to do, and then whatever you get out of that, we're going to solve with the techniques we've already been using for solving equations. So here's an example. We see an equation now, and there's a bracket in it. So first thing we're going to do is we are going to expand that bracket. 5 times b minus 5 times 3. And you see I'm doing that a little faster than I showed on the last slide there. You can show the extra step if you want to, if it helps you. But once you get good at it, most people are pretty happy with the 5 times b minus the 5 times 3. And everything else is just there as it is. And now we want to solve this. There's a few different ways we could go on this, and I don't actually remember which one of them I chose. Yeah, so what I've decided to do here is move away both of those constant terms. I could have also combined them first. I could have combined the negative 15 and the plus 8, so that would have combined to negative 7, and you would have got the same answer. But in this case, I've decided to move them both separately. So the minus 15, the subtracted 15 becomes an added 15 on the right, and the added 8 becomes a subtracted 8 on the right, like so. And again, what we know we just did is added 15 to both sides and subtracted 8 from both sides. And now we can put that right side together. 33 plus 15 is 48. And you see I still have the negative 8 there. 48 minus 8 is 40. And maybe we'll pause here and notice that if I had joined them together up here, subtracted 15 and added 8, that's 15 left and 8 right, which works out to minus 7. Then I would have added 7 over to the right side. 33 plus 7 is 40. I would have got the same thing. Finish this off. Both sides need to be divided by 5. 5 over 5 cancels, leaving just the b, and on the right, 40 divided by 5 is 8. So there's our first nice simple equation that has brackets. You see it's really nothing that we weren't already doing. We just have to expand the bracket first and then follow the same rules we were already following to get the variable by itself. Here's another one. And you can see this one has brackets on both sides, and that's okay. Let's expand them all. So I've done some coloring there. Let's see. I got the plus 8 in blue, and that's just going to continue to hang out back here because it doesn't go away, so it's always going to be there. I got this plus sign in red and this minus sign in green. Oh, I didn't do my little curly lines on that one. So you see this 4 multiplied into the bracket. 4 times z and 4 times 5 with a red plus sign between them. The 2 multiplied into this bracket, 2 times z and 2 times 3 with the green minus sign between them. And like I said, that plus 8 at the end, it's just there. Don't let it disappear. Again, remember we've talked about lining up those equal signs, how important that is to keep all your work organized. And again, I would recommend writing the next line's equal sign first and then figuring out what goes on each side. So 4 times z is just 4z, 4 times 5 is 20, 2z, 2 times 3 is 6, so 2z minus 6 plus 8 is still there, right, hanging out at the end. And now let's see what we want to do. Well, I got z's on the left, I got z's on the right. I want to get them all into one side, so I think I'm going to be subtracting this 2z over to the left because it is being added right now, and subtracting that 20 over to the right. I decided first to join those together this time. So I got a minus 6 and a plus 8, and I looked at that and I thought, well, that's easy. Let's just do that. 6 to the left, 8 to the right. On the number line, imagine it. 8 minus 6 is 2, so I went a total of 2 to the right once those are put together. All right, now I think I'm going to say, let's move that 20 over to the right, and let's move that 2z, which we know is being added, right? When we don't bother to write the sign in front of it, it's being added. So the added 2z on the right becomes a subtracted 2z on the left. You see that in blue. The added 20 on the left becomes a subtracted 20 on the right. You see that in red. And now we can collect like terms on the left. 4z minus 2z is 2z. On the right, positive 2 and minus 20. So that is going to be, remember, if they go in opposite directions, you subtract them. 20 minus 2 is 18. Which one is bigger? Which direction are we going further? We're only going 2 to the right. We're going 20 to the left. So that's going to be negative 18. 18 to the left on the number line. And now I just got to get that z by itself by dividing both sides by 2. And negative 18 divided by positive 2 is negative 9. All right, so that one is a little more involved, but again, you see all we do, look at this first step, expand the brackets, and then we just end up with an equation that we already knew how to solve. So here is a couple for you to try. The only thing I'll mention here, no, I'll mention that afterwards. So take a pause if you're doing the video, and pause and try these. If you're in the class right now, we'll give you maybe 4 minutes or so to give those a shot and see. If you're not sure, just get as far as you can. Expand the bracket and then see if you can do anything from there. If you're, sometimes people look at these and they're like, I don't even know. Just try to take the first step and see what happens from there. Okay, so let's walk through these. This first one here is, by the way, I did this on purpose, the exact scenario you might run into in Math 052 or 038, where you need to solve. And this is especially 052, and this would be if you have a perimeter and they tell you what the perimeter is. They tell you the perimeter is 26 meters, say, and they tell you the only other information you have is that the width is 5 meters shorter than the length, and that's what that L minus 5 is there. This is the equation you end up building from that, and the only way to work out the answer to find the length and the width of the perimeter or of the rectangle is to do some basic equation solving like we're about to do. So we see that bracket there. We know that before we do anything, we want to expand the bracket. So the minus is going to stay a minus, that red minus sign, and the 2 is going to multiply by both of the two things in the bracket. So 2L plus 2L minus 2 times 5, like so. And then let's tidy that up a little bit. 2 times L, that is a bracket that's not doing anything, so we can just write, we got 2L here that's carried along. Now we got another 2L, and then 2 times 5 is 10. A little bit of collecting, 2L plus 2L, let's put those together because that's just 4L. And now we have taken this complicated looking equation with a bracket and we have turned it into our classic two-step equation. We have a constant term to get rid of first, and then we will do some dividing to get our variable by itself. So the subtracted 10 on the left becomes an added 10 on the right, as we are hopefully getting very used to now. What is 26 plus 10? It is 36. And is the L by itself yet? No, it's not, because it's being multiplied by a 4. How do we get rid of a multiplied 4? We divide by 4, and whatever we do to one side, we do to the other. 36 divided by 4 is 9, and on the left, of course, the 4's cancel out, just leaving an L. So there is that first equation solved. And if we were doing that perimeter question I described, the length of the rectangle is 9, and then you would go back and work out that the width is 5 less than the length. I didn't give any of that context, in the slideshow, just sort of throwing that in there so you have an idea of where you're going to run into these types of equations. This one here, a little bit more complicated. We got brackets on each side. We got variables on each side, so there's going to be a little bit more involved, but we want to expand those brackets. And again, we see the color coding. We got a red plus sign is going to stay there when I multiply the 4 by the two things in that bracket. The green plus sign is going to stay there when I multiply the 7 in by both things in that bracket. And we're going to have a blue plus 2 that's just going to continue to hang out at the back there. So there is all of our brackets expanded. 4 times d and 4 times 1 with a plus sign between them, 7 times d and 7 times 3 with a plus sign between them, and the blue plus 2 just hanging out. Let's simplify. This bracket isn't doing anything. 4 bracket d is just 4d. 4 times 1 is 4. Same with 7 times d is just 7d, and 7 times 3 is 21. And we still have the plus 2 there. Let's try and clean this up. I think I'd probably like to collect that 21 and that 2 first together. So we have an added 21 and an added 22. Sorry, an added 21 and an added 2 makes 23. And now I've got variables on the left, variables on the right, constants on the left, constants on the right. I want to get all my variables to one side and all my constants to the other. So what I've decided to do here, it looks like, is I'm going to take that added 4 on the left and make it a subtracted 4 on the right. The added 7d on the right becomes a subtracted 7d on the left. The reason I did this is because now look carefully. I have all of my variable pieces on one side, all of my not variable pieces on the other side. So collect them together. 4d minus 7d is negative 3d. That's 4 to the right and 7 to the left. Negative 3. 23 minus 4 is 19. And now to get the d by itself, I divide both sides by negative 3. And that's going to be a fraction. 19 over negative 3 is negative 19 thirds. Or if they want a mixed number, 3 goes into 19 6 times with 1 left over. All right, so expand the brackets, see what you have left, move the pieces around so all the variables are on one side and all the numbers are on the other, if necessary. Sometimes that's already done for you. And then take your final step of dividing. And oh yes, so let's remember we can always check our answers. This is the second superpower of equation solving. The first is we can do anything we want as long as we can do it to both sides. The second is that you don't just have to hope your answer is right. You can check to see if your answer is right. So for this second equation, we got an answer of negative 9. I think for the sake of time, I'm just going to go through this instead of pausing and letting you guys try it. But we're going to plug in that z equals negative 9 to both sides, and we're going to verify that it makes the left side and the right side the same as each other. So the left side of this equation is 4 times z plus 5 in blue. The right side is 2 times z minus 3 plus 8. And I'm not going to expand those brackets and recollect and do all the same things I did to solve the equation, because then if I made a mistake, I'd probably just make the same mistake again, right? What I'm going to do is test to see, does negative 9 actually work? So checking your answer doesn't mean solving the equation again, right? It means plugging it in. So I am going to replace all of those z's with negative 9, like so. on both sides of the equation. This is one of those situations where the bracket isn't doing anything. Let's remind ourselves, what are the things brackets do? Either there's something inside the bracket to be worked out. Nope, inside the bracket is just a -9. There's no BEDMAS to work out in there. Or the bracket represents multiplication, but no, there's nothing right against that bracket. So this bracket's just doing nothing. So we can drop that inside bracket there around the -9. Now let's take the left side first. BEDMAS, we're going to work this equation, this expression out. Inside the bracket, we have -9 plus 5, so that's 9 to the left, 5 to the right. 9 minus 5 is 4. We went further left, so -4. And then multiply 4 times -4 is -16. Over here in this bracket, we have 9 to the left and then another 3 to the left, so we went a total of 12 to the left. We add those together, -12. 2 times -12 is -24. -24 plus 8, again, we're going in opposite directions, so subtract those two and you get 16. We went further left than right, so it's -16. And sure enough, our answer of z equals -9 makes the left side and the right side both equal to the same thing, in this case, -16. All right, so I think I got a summary, and I think that's it. Yeah. So if an equation has brackets in it, we simply expand the brackets first and then do all the stuff we already know how to do to isolate the variable.